Hello friends, सबको नमस्ते. So today in this video we will create a emotion classification using a YOLO model. So I already downloaded my, or you can say uploaded my dataset in my different Google Drive. So just I copy the share link and capped this part. You can directly download the zip file from different Google account to the Google account which is currently you are using for Google Colab. Okay, just keep this part and it's ready to go. Just this cell, your zip file will get downloaded. You can see it. Okay, let me refresh it. See, this is zip file. Now we have to unzip it. Okay, now let me show you the data set that we are using. Okay, so this is a data set which contains two folders: test and train. In train we have a multiple folders for anger, for fear, for happiness, for neutrality, and for sadness. For anger we have images 860, and for fear we have images 545. Now you can see that we have a number of unequal or undivided number of images for each category or classes, we can say. So we have to increase the number of images by using a data augmentation. I can tell you in the code how we can add a data augmentation. We have to install the package Ultralytics to import the YOLO model. Now we have to import the YOLO model. Now we have to use upload the YOLO11 al CLS PT, okay, using a YOLO. So you can see this YOLO11 have multiple classification models. You can say N, S, M, L, and X, and the difference is of parameters and multiple factors are different. But mostly we mostly we can see only the parameters. So YOLO11L CLS have 12.9 million parameters, and the size on which it's trained is 224. Okay. So after loading it, you have to train this model on a custom data set. The custom data set which we have is a phased emotion detection, emotion classification, not detection. Okay, now for that we have to use model.train. Now just to give the dataset folder, this is like this emotional dataset. Then the epoch is 50, but I already have a model which is trained on 50 epoch. After epoch of training with the 5 epoch, I will upload that model with 50 epoch and show the result of both the model which is trained on 5 epoch and the model which is trained on 50 epoch. You can clearly see the difference between them. Now image size will be 224 because usually the classification model of YOLO work with 224 image size, and the batch is 8, means when the images is divided into the batches, I want 8 images should be there present in one batch. Now when you will run this cell, you will get you will see that run folder get created, and inside the run folder classify folder will be there, and inside the classify folder you will get one folder whose name which will be decided by us, and we decide the name is emotional dataset YOLO11. What is the importance of this folder is that inside that folder you will get the weight folder, and inside the weight folder you will get the weight file which can be used for the prediction in the future. Now save true means we want to save the weight file. Now save period -1 means we do not want to save every weight of each epoch, we just want to save the best weight file. Now patience 20 means early stopping. We can stop the training after every 20 epoch, means if after 20 epoch accuracy does not increase or the loss does not decrease, so training gets stopped and the best model will get saved. Now I already told you that our number of images is less, so to increase the variation and also the number of images, we add data augmentation. So these are the attributes which we can use to increase the data augmentation, or we can say number of images: degree, flip, skip, share, translate. Okay, now let me run this cell. Our training is get started only for the 5 epoch. You can see it. See, this run folder get created by default. So let's get started. See here, GPU memory, which is utilized during training. Loss is a classification loss, and here is this 493 is a number of batches which is used for training. Okay, so let me explain now this part. See, now we have training cat over. Now inside this run folder, I already told you that classify folder will be there. Inside the classify folder, the folder name which we have decided, inside it the wait folder will be there. Okay, when this epoch 1 will get completed, you will see that best and last, you can say 2 wait file will be there. Let me show you. So it's get completed. Okay, that's completed. Now let me refresh it. Now you can easily see that best and PT and last PT fold means the wait file will get ratio. Now to upload, now we have to upload that wait file using your YOLO. So this is YOLO and the wait file which we have uploaded. Okay. Now the test, you can see you have to, for testing we have to give the test folder directory. So here the test folder directory, you can see that inside the test folder multiple folder with classes name and the images inside them. Now this is, we have to make the list of all the folder present in that particular directory. Means it make a list of anger, fear, happiness, neutrality and sadness. Okay, now I have to plot 16 images. For plotting of 16 images, there should be 4 rows and 4 columns. So here 4 rows, 4 column, and each figure size will be 16 by 16. And here figure basically representing the entire subplot, entire plot, not subplot, entire plot. Here x is used for the iteration towards the subplots. Here basically in this line x is in a 2D format, but when I will use x ax dot variable, it is converted to 1D dimension. Now just for the protection of 16 images, I have to use loop for loop for 16, and just then we have to select a random. That image folder, basically I told you that it contains the list of all the folders present in that particular test directory. Now first we have to select the folder, randomly select the folder, and when I have to select randomly select the folder, now I have to make the list of all the files present in that particular folder. For that I have to use OLS directory. Then I have, inside that OLS directory, I have to pass the directory name. Okay, for that I have to use os path.join test images folder, means this one. Till here we will get out. After that I have to give the folder name. For that I have randomly select the folder name. Now this way I make the list of all the file name present in that particular folder. Now after that I have to randomly select the file name also. For that, in just image path I have to create for that os path test image directory, then the folder name which I have select randomly, then I have to randomly select the image file from this list which I have created. Okay, this way our image path get ready. Now we have to read that particular image. Now here see, either you can use result and erase this. This line is not required here. Okay, just skip it, 0 here. Now let me see what is either you pass for the prediction purpose, either you pass image path or the image, there is no effect. Okay, or you can say no error will be shown. It's up to you. Either you can pass image path or image. Okay, now here what is the use of 0? Because I only passing one image, so I want only the zero index result only. So that's why I have to use 0 here to get the result of the image which I have passed. Now see, let me print first model dot names, which give me that which class ID belongs to which class name. Now print, you can see I'm taking the information from result.props. So let me print that. Let me first print result, then result.prop, so you can get better understand of what is happening here. Okay, so let me print a break here. See, let me see that the training, yes, our training got over. Okay, so let me see how our model is working when it's trained with 5 epochs. There is no folder of dataset. Now let me run this. No such a directory. What's the problem with? Oh, sorry. Not 2. It should be 11 only. Now let me run this. See this. First important thing. What happened first? Model.names. See, model.names give me this detail. 0 for anger, 1 for the fear, 2 is for the happiness, and 3 for the neutrality, and 4 for the sadness. These are the class ID which belongs to which class names. Now, after getting to this detail, now see, result is this thing here. Results start from here, from boxes till here. It's ends here, and you can see that here this one attribute can say props basically contain all the result. Okay, so what is this result dot prop? Result dot prop basically is a you can say dictionary. Here top one, see here tensor data 0 3 point this. How many classes which we have? See how many classes we have. Anger 1 2 3 4 5 5 classes we have. So here 5 digit will be there. 1 2 3 4 5 means particular image belong to which particular class probability, or you can say a percentage value or anything you can call. It's giving the value that particular image belong to which but how much it's similar to that particular emotion, particular image. So 3770, not top one. What is the meaning of this top one? Top one basically give me the class ID whose probability is highest in among the emotion or because among the class names. Now top five, top one confidence means the confidence which we want. See 0.3 of 2304230 means 4 class ID, and the 4 in this 4 are the confidence will be this 0.4230. These are the confidence. So this way we retrieve the information. So how are retrieving it? See, first I result.prop.top one, I get a class ID. Now model name, give me the class name. Now for getting the confidence, just result.prop top one count.item will give me the confidence. Now see, all I have read the image in a CV2, so I have to convert that image into the RGB format. So that's why I've used CV2 CBT color, okay, into VGR. Now just plot that image. Now I have to plot actual also, predicted also, and see actual will be the image folder we have selected randomly. It should be the actual. Now prediction is decided by this class name, so that's my class name, and confidence is this one. Now let me run this so that I can give the result of the model which is trained on 5 epoch. See, let me see how much it's working good. Happiness correct, anger correct, happiness correct. One wrong here, correct, two wrong, three wrong, four, and five. Means 5 among 16, 5 images predictions are wrong. Now let me upload the model which is trained on 50 epoch and see the result of that model, how the prediction is done with 50 epoch model. Okay, so let me come back, let me pause this video and come back when my uploadation of that model gets completed. Okay, so the uploadation is complete. Now let me show you the result of the model which is trained on 50 epochs. See the result. Let me show the means how many predictions are wrong. 1 2 3 4 5 6 7 and 8, and you can see that mostly anger multiple images means to increase the accuracy or the prediction you have to increase also have to increase the epochs by 50 also, or you can increase the number of images by adding the data augmentation. Okay, one more, 1 2 3 4 5 5. Okay, so this is all. You can now for that increasing of accuracy, now you can increase the number of images, or you can increase the data augmentation. Okay, or epochs value you can increase. So it's up to you. So I already explained you each and everything. Now you can download this model and use it anywhere you want to use. So please like, share, and subscribe. Thanks to all.